Today I'm going to be deriving Kepler's third law of planetary motion, which states that for any orbit, the square of the time period of that orbit is proportional to the cube of the radius of that orbit. Now we can derive this by looking at one body orbiting another, one larger, one smaller, and we can say that the centripetal force which causes that circular motion, Fc, equals m omega squared r. That centripetal force is represented by the attraction of gravity, which is usually showed by minus gmm over r squared. To keep things simple, I'm not going to use the minus, and we're just going to use gmm over r squared. So if these two are the same in this context, that means I can equate them, which means I can write gmm over r squared equals m omega squared r. Now on both sides I have little m, so I can just cancel that out. And I have an r here and r squared over here, so I'm going to multiply both sides by r squared. This leaves me with gm equals omega squared r cubed. Okay? Now we've got r cubed over here, but we're still missing t squared. So what we're going to do is we're going to think of an equation that relates omega to t. First, we know that omega is angular speed, which is equal to 2 pi multiplied by angular frequency. And we also know that angular frequency is the inverse of time period. Putting these two together, we can find that omega equals 2 pi over t. And subbing this into there, we can form a new equation that says gm equals 2 pi over t all squared multiplied by r cubed. Now remember, for this we have to square both the 2 and the pi, so expanding this out gives us gm equals 4 pi squared over t squared multiplied by r cubed. And you can see we're almost there because we have our t squared and we have our r cubed. So what we're going to do is we're going to bring the t squared over here by multiplying both sides by t squared, and we're going to bring this gm over here by dividing both sides by gm. What that gives us is t squared equals 4 pi squared over gm multiplied by r cubed. Now in our context, the big M, the mass of this larger body, is fixed, which means 4 pi squared over gm is fixed. So we're going to let that be a constant. We're going to say 4 pi squared over gm equals k. So substituting that into there, we can say t squared equals k r cubed. And where we have an equals k, this reduces to a proportionality. So we just have t squared is proportional to r cubed, which is what we set out to prove, which is Kepler's third law.